Now, there's a certain way in which we work out, when we do these crossings, when we work out how alleles are transferred and where we can predict what the phenotypes and the genotypes of the offspring will be. And Colin is going to take you through the template. And this is important. Now you have to concentrate, because at the end of the year, when you write your paper, and in June and September as well, you must do it according to this template in order to get full marks. And once you understand this, people, it is Pasella marks. You must get it. Colin, let's see.
Yeah, we can say it's at least you can think about 5 to 6 marks that is there. First of all, we work with certain traits or characteristics. In this instance, I'm going to use an example, this shape of seeds. And the alleles that we're going to use is a capital R for round seeds and a small R for wrinkled seeds. And this shows us immediately. What you have to know is whenever you see the capital R, it shows that it is the dominant allele. Now, where do we start? Never ever forget that you must have parents, and you must indicate the P1. We want to see the P1, and we want to know what you can identify eventually as the F1, because we link up the two and we give you 1 mark. So when you indicate your P1 and your F1, you already have a mark for the exam. Never forget, so you only need 149 more. There we have the phenotype. The phenotype, the visible characteristic, what you can see. So we're working with round seeds, and we're also going to use another round seed. So here we have 2 round seeds. But if it is said that we work here with 2 heterozygous round seeds, remember, you can't say in your phenotype it's heterozygous, because heterozygous is your genotype. So you never mention here whether it is heterozygous or homozygous, because that is not visible. It's not in the phenotype. You can only say it's heterozygous by indicating it by using the correct alleles in the correct order. So you always use your capital R in front. So here we have the P1 generations, 2 heterozygous round seeds. Remember, make a note of it. You never indicate in your phenotype that it is homozygous or heterozygous. The next step is gametes need to be formed, and the process by which it is formed is meiosis. You indicate meiosis merely by making 2 little down lines there, and your gametes. What does Mendel's law of segregation say? It states that during meiosis and during the formation of gametes, these alleles separate, and you can see the separation. And now we're going to, now only fertilization can take place, and we're using this Punnett diagram. And now you must make sure that you see. This work has been done in the first term by most schools. So if we go a little bit fast, you must know we only have a limited time, because we still need to touch on to the other aspects. But let's look. First of all, we place our alleles and our gametes there on the outside. What did we say earlier on? The female gametes on top and the male gametes. In this instance, it doesn't matter now, because it's both the same. Now we're going to cross over. This is now the cross that's going to happen to see what our possible offspring could look like and the genotypes that they could have. If you cross off this one, you first cross this one with the top one there, and this is what you get. Then you cross the next one, the same one with the one next to that, and this you get a heterozygous round seed. So here you have a homozygous round seed, heterozygous one, and now you go the other way. And what do we get? Another heterozygous round seed, and we get a wrinkled seed. So whatever we have found in our Punnett square...
How do they know that's the wrinkled seed? You say that's the wrinkled seed.
Because we started off with 2 round seeds.
Oh, but how do they know that that one is going to be the wrinkled seed?
And I hope they
Just
remember.
to wake them up.
We hope they remember.
Let's have a look.
If you look at it once again, earlier on we said, if we have, for instance here, you have a heterozygous organism, the dominant allele masks the presence of the recessive allele. And this is exactly what we see here. It's round, Why? The small r, which represents the wrinkled one, is recessive and it is masked. It dominates the recessive allele, and that means you can't see it in the phenotype. But here, the only way, as we said earlier on, that you can have a wrinkled seed, which is the recessive allele, if it is both recessive alleles you inherit from both parents. And once again, here you have, whatever you have found here is your F1, and you have to indicate it again. So we started off with a P1, and we have our F1. What is this? It's our genotype. And the genotype is the genes, the genetic makeup of the organisms that you see here. And the phenotype, what did we get? One round, another round seed, another round, and one wrinkled seed. And this is also very important. When you look at the ratio, you have 4 seeds, possible offspring here. The ratio, the genotypic ratio is 1 to 2 to 1. What does that mean? We have 1 homozygous round seed, 2 heterozygous round seeds, and 1 wrinkled seed, which means the genotype. But why does the phenotypic ratio differ from the genotypic ratio? It's 3 to 1. Because what do we see? We can't see the genetic makeup, but what we see is we have 3 round seeds and 1 wrinkled seed. Make a note of it that you can distinguish between the genotypic ratio as well as the phenotypic ratio. And there you have 6 to 8 marks sometimes for a monohybrid crossing.
And Colin, it's actually fantastic if our learners know how to do this. As you say, it can be anything from 6 to 8 marks. It's fantastic.
It is.
And we've been having so many questions. And when I ducked in and asked you about the wrinkled seeds, we've got them, all the answers here. There's a lot of people, a lot of our learners from Mount View and Allo saying that it is because it's the 2 small R's. So well done. Seems that you understand. Could we quickly go through it on paper?
I think so.
And have a crossing and see once again, step by step, where we are. What you're going to write is, let's say we've got a brown mouse and a black one. Okay. The brown mouse, we're going to use bees again, is homozygous for the brown color, which is dominant. The black mouse is the recessive one. So in this case, what you will have here, you can write meiosis, and you will have your 2 gametes, right? Here you've got your gametes. This, of course, is the P1 phenotype. And Colin wrote on the slide gen ratio and fen ratio. Please don't do that. She only did it because there wasn't enough space on the slide. You have to write out the words. Then we get to genotype. Okay. Now the reason why I'm doing this is simply because there was a question from one of our viewers. What and how do you do this if you are simply asked to do the genetic cross? Could we have the paper, please? If you're simply asked to do the genetic cross and not a Punnett square. Now, if they want a Punnett square, you will be specifically asked to do it. You can do the genetic cross in another way as well. The Punnett square just makes it so much more easy and so much or so less chances of making a mistake. But you can do it like this. Have a look. When you do genetic crossing, remember we're working with probabilities. So you have to see what's going to happen if that gamete fuses with that gamete. Capital B, small b. What if that gamete fuses with that one? Right, now you've done that one. So what if that gamete fuses with that one? Or that one with this one? And this is where you sometimes have problems, because especially learners that write small letter, sort of very small handwriting or a bit messy, you sometimes tend to make lines to different places where they shouldn't be. Can you see? It's totally acceptable if you are only asked to do a genetic cross. But the moment they ask you to do a Punnett square, then you have to do it the way that we've just had on the slides. So let's continue with the slides.
And just for their sake, it is acceptable to do anything if not specifically asked that you must draw the Punnett
You must
square.
just get to the answer.
Whichever one works better for you,
Yeah.
it's okay.
There's a second question that asked, how does the ratio work? Now, if we have, let's say, if we have RR, and we've got 2 of these and 1 of these. If we look at them and we add up, it's 1 of the homozygous for that characteristics, 2 of these and 1 of this. Now, with the ratio, this is the way that you write it. Capital R, or homozygous is to capital R, small r, or heterozygous is to small r, or the homozygous, as 1 is to 2 is to 1. It means that for every 1 of these, there are 2 of these, and there's 1 of these. But this is the way that you write the ratio. Now, all 3 of those in the phenotype would have been, let's say the characteristic is red, and all of these would be yellow. So now you'll write your phenotypes. Red is to yellow as 3 is to 1. This is the phenotype. This is the genotype. This is the phenotypic ratio. This is the genotypic ratio. Colin, I don't know about you, but I often find my learners think that the numbers is the genotype or the phenotype. But it's not.
No.
It's not. You will ask them and then they will just write the numbers.
And I think this is a very good way of showing them how the ratios work.
Okay.
Just remember, and don't mix it up, because we still find so many learners that they mixed up the genotype and the phenotype. Remember, phenotype is what you see. The genotype, you can't see. It's on the genes.
Yeah, and they are allowed to use percentages as well.
Yeah.
But then once again, the way of writing is important. Let's continue. We've got lots to show you in so little time.
The next slide is such an important slide because these are the possibilities of what they could ask. If they ask you, and I'm so glad that Lorraine has showed you now, that if you have 2 homozygous organisms that are being crossed, all of them will be heterozygous with a dominant allele seen in the phenotype. She had the brown and the black, so all of them will be heterozygous brown. And that is 100%. Here you have, if you cross 2 heterozygous organisms, then you get the ratio, the genotypic ratio of 1 to 2 to 1, which is 3 brown and 1 white. And then you have your the other possibilities when you have a heterozygous and 1 homozygous. Remember, it can be 2 capital B's here, it doesn't matter. But if you have a heterozygous and a homozygous organism that you cross, then you get it 50% to 50% ratio, which means that you can get 2 brown and 2 black. And these are the possibilities that they can get, and if they can memorize that, even better.
And they also use the last one. Could we have the slide, please? They also use the last one, as you can see here, this as a test cross. If I want, let's say I've got a dog, and in Labradors, hip dysplasia is a big problem. And now the breeder that I buy it from tells me, no, this dog is fine. It's a recessive characteristic I want to see. Now, it's a cruel crossing, but what one could do is cross it with one where the characteristic is visible, in other words, where it is homozygous for the recessive trait, then there's a 50% chance in the offspring that the characteristic will also be visible, will pop up. So a test cross, you want to see, you cross with 2 small b's, or whatever letter you use.